Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School Islamabad campus. Today I am going to conduct an AI session with Maya. In this session, I will ask two questions and Maya will provide answers. So let's start. Okay, Maya, my first question is, what is software?
The classic. At its simplest, software is just a set of instructions that tells your hardware exactly what to do. Think of your computer or phone like a highly skilled musician, and software is the sheet music. The hardware has the capability to make the sound, but without the music, it's just sitting there. Whether it's the operating system keeping everything running in the background or an app you use to scroll through photos, it's all just code translated into actions. Where do you want to start digging in?
Okay, Maya, my next question is, what is the difference between software and hardware?
Think of it as the brain versus the body. Hardware is the physical stuff you can actually touch and kick, like the screen, the chips, and the battery. Software is the invisible part, the instructions and code that tell those parts how to behave. One is the machine, the other is the mind that makes it useful.
Okay, my next question is, what are the main type of software?
You can split software into two main worlds: system software and application software. System software is the foundation, things like Windows or Mac OS that keep the hardware running. Application software are the specific tools we actually interact with, like Chrome, Spotify, or whatever app you're using right now. What's next on the list?
Okay, my next question is, what is system software?
System software is the invisible engine under the hood. It's the software that manages and controls the computer hardware so that application software can actually perform its tasks. The most famous example is the operating system, like Windows, Mac OS, or Android. But it also includes things like device drivers that tell your computer how to talk to a printer or a graphics card. Basically, it's the bridge between the physical machine and the apps you use. What's next?
Okay, my next question is, what is application software?
Those are the tools you actually use to get stuff done. Think of it as anything that's not the operating system. It's your web browser, your music app, a spreadsheet, or a game. While system software runs the machine, application software lets the person using the machine actually do something useful with it.
Okay, my next question is, what is programming?
Think of it as the art of talking to a machine. It's the process of creating those instructions we talked about. Since computers only understand in ones and zeros, programming is like using a specialized language to translate human ideas into something the hardware can actually execute. You're basically writing a very detailed recipe that the computer follows exactly without any room for just winging it. What's next on the list?
Okay, my next question is, what is coding?
Think of it as the actual handwriting um, part of programming. If programming is the whole process of planning and designing the recipe, coding is the act of actually writing it down in the language the computer understands. It's the nuts and bolts, the line by line work that turns the plan into something real. Want to keep rolling? I think we got a little mixed up. What were you referring to?
Okay, my next question is, how is software developed?
That's where the real magic happens. It's a process called the software development lifecycle, or SDLC. Think of it like building a house. You don't just start nailing boards together, you need a plan. It usually goes like this: planning, where you figure out exactly what the software needs to do, then design, where you sketch out how it'll actually look and work. After that is the coding part, which is where the actual writing happens. But once it's written, it goes to testing because the first version of any software is almost always a bit of a mess. Finally, there's deployment and maintenance, which just means releasing it to the world and fixing the bugs that inevitably pop up. Which part of that sounds the most interesting to you?
Okay, my next question is, what does a software developer do?
Basically, they're the ones who build those recipes we talked about. It's a big job that actually varies depending on what they're building, but it usually boils down to problem solving. They spend a lot of time in the planning and design phase, figure out the logic of how a feature should work, and then translate that into code. But most of their actual day is spent debugging, which is just a fancy way of saying they're playing detective to figure out why the code isn't doing what it's supposed to. They also have to collaborate with designers to make sure the app actually looks good and works for real people. What's next on your list?
Okay, my next question is, uh, how does AI help in software development?
It's kind of like having a really fast, really eager intern who never sleeps. In the past, you had to hunt through forums for hours to find a fix for one bug. Now AI can spot that error in a second and suggest a fix. It handles the tedious stuff like writing, repetitive boilerplate code or generating test cases, which lets the actual developers focus on the big picture. But, the interesting part is how it changes the job. Instead of just writing every line, developers are becoming more like editors or architects, reviewing AI suggestions and making sure the final product actually makes sense. It's making the entry barrier lower for beginners, but the ceiling for what a great developer can do is getting even higher. What's the next question?
Okay, my next question is, uh, what is Chat GPT?
I'm guessing you mean Chat GPT. It's a large language model, which is basically a piece of software trained on a massive amount of text to understand and generate human like language. In the software world, it's become a huge deal because it can actually help write and debug code, which is exactly what we were just talking about. What else you got?
Okay, my next question is, uh, which programming language is best for beginners?
Python is usually the top answer. It's designed to be read almost like English, which means you can focus on learning the logic of programming instead of fighting with weird syntax. Plus, it's incredibly versatile. So, whether you're into data science, AI, or just automating the boring stuff in your life, it's a great place to start.
Okay, my next question is, why why is Python so popular?
Um, Honestly, because it's just so friendly. It's one of the few languages that doesn't feel like you're fighting the computer just to get it to print hello world. That readability makes it the go-to for master.
Okay, my next question is, what is the difference between Python and Java?
Python is like sketching in a notebook. Java is like drafting blueprints for a skyscraper. In Python, you can just start writing and it works, making it fast to build things. Java is more strict. You have to be way more explicit about everything. It's slower to write, but that structure makes it a beast for huge complex systems like banking apps or Android. Python wins on ease, Java wins on industrial scale. Next question.
Okay, my next question is, what is HTML?
HTML is essentially the skeleton of the internet. It's the language used to structure a web page. Doesn't make things look pretty or do anything fancy. It just tells the browser where the header goes, what's a paragraph, and where to put an image. What's next?
Okay, my next question is, what is CSS?
If HTML is the skeleton, CSS is the paint and the interior design. It's what takes a plain white page with black text and turns it into something that actually looks like a modern website. It's all about the fonts, the colors, and exactly where things sit on the screen. So you've got the skeleton and the skin. Ready to talk about the brain?
Okay, my next question is, what is database?
Think of it as the digital warehouse for everything a piece of software knows. While a variable in a program is like a sticky note that gets thrown away when you turn the computer off, a database is where information is stored permanently. It's not just a giant list, though. Most databases are organized so you can find exactly what you need in milliseconds, even if there are millions of entries. You've got relational databases like SQL, which are like a series of perfectly organized spreadsheets. And then you have no SQL databases, which are more flexible, like a collection of digital folders. Without them, every time you refreshed a page or logged into an app, the software would have to start from scratch. What's next?
Okay, okay, my next question is, what is the difference between a website and software?
Honestly, that's a bit of a trick question. The short answer is that a website is actually just a specific type of software. The real difference is just how you access them. Software usually lives on your device and runs locally, while a website lives on a server and you use a browser like a window to look at it. But these days, the line is totally blurred because most websites are really just complex software applications that happen to be delivered through a tab.
Okay, my next question is, what is API?
An API is like a waiter at a restaurant. You don't actually go into the kitchen and mess with the chef. You just tell the waiter what you want. They take the request to the back and then they bring the food back to you. In tech, it's the same thing. One piece of software asks another for something specific. The API handles the request and brings back the data. It's how your weather app gets the forecast from a server without having to be a meteorologist itself. What's next on the list?
Okay, my next question is, what is JavaScript?
If HTML is the skeleton and CSS is the paint, JavaScript is the nervous system. It's what makes a website actually do things. Without it, you just have a static page that looks pretty but doesn't move. JavaScript is why you get a pop up when you click a button, why a feed refreshes without you having to reload the whole page, or why you can play a game right in your browser. It's basically the difference between looking at a picture of a car and actually being able to drive it. Next question.
Okay, my next question is, what is desktop software?
That's software designed to live and breathe on your computer's actual hardware. Unlike a website, it doesn't need a browser to function. It has direct access to your system's resources, which is why things like high end video editors or pro gaming software are built this way. They need that raw power without a middleman. What's next?
Okay, my next question is, what is how are mobile app created?
It's like choosing the right tool for the job. There are two main ways. First is native development, where you build the app specifically for one system using its own language, like Swift for iPhone. It's the gold standard for performance because it speaks the hardware's own language. And there's cross platform, where you use one set of code to launch on both. I'm intrigued. What have you got for me?
Okay, my next
The
question
floor is yours.
what is debugging?
Go on. Think of it like playing detective in your own code. When you finish writing a program, it almost never works perfectly the first time. There's usually a bug, a mistake in the logic, or a typo that's causing a crash or a weird glitch. Debugging is the process of hunting that mistake down, isolating where it's happening, and figuring out how to fix it without breaking something else. It's often the most frustrating part of the job, but it's where you actually learn how the software really works. What's next on your list?
Okay, my next question is what is open source software?
Think of it like a public recipe. Most software is like a secret family recipe that only the company knows. Open source is the opposite. It's software where the original code is made public for anyone to see, modify, and distribute. It means developers all over the world can collaborate to fix bugs or add new features, which is why things like Linux or Android became so powerful. It's basically the community project version of tech. What's next?
Okay, my next question is what is software testing important?
Because nobody wants the app they're using to just like vanish into thin air the second they click a button. It's basically a safety net. Without testing, you're just hoping for the best, which is a terrifying way to launch a product. Testing catches those tiny typos or logic gaps that would otherwise turn into full on disasters for the people actually using the software. It's the difference between a polished experience and something that feels like it was held together with tape. You want to dive into how they actually do the testing or move to the next one?
Okay, my next question is what is closed source software?
Closed source is basically the opposite of the public recipe. It's like a corporate secret that only the company knows. The code is locked away in a vault, so nobody but the developers who built it can see it or change it. This is how most big apps like Microsoft Word or Photoshop work. It lets the company maintain total control and makes it easier for them to sell their software as a product, though it means you have to trust them to fix any bugs they've left behind.
Okay, my next question is uh, what is an operating system?
It's the ultimate multitasker. The operating system is the software that manages everything else on your device. Think of it as the conductor of an orchestra. It tells the CPU when to work, decides how much memory your browser gets, and make sure your keyboard actually talks to your screen. Without it, your computer would just be a collection of very expensive metal and plastic with no way to actually turn it on or run a single app. It's the layer that lets you interact with the machine without needing to speak in ones and zeros.
Okay, my next question is why is software testing important?
You're checking my work. I already gave you the safety net answer. So here's the other side of it. Testing is all about predictability. You want to know that when a user hits send, the message actually goes and doesn't just trigger a random error message. It's the only way to make sure the software actually does what you promised it would do. You still want to dive into how they actually do the testing, or do you have a brand new one for me?
Is okay, my next question is what is Git?
Think of Git as a super powered undo button. It's a version control system, which is just a fancy way of saying it's a way to track every single change made to a project. Imagine you're writing a book and you're about to make a huge change to the ending. Instead of just hoping it works, you use Git to save a snapshot of your work. If the new ending is a disaster, you can just teleport back to that snapshot and start over. It's a lifesaver for developers, especially when they're working in teams, because it lets multiple people edit the same files without accidentally overwriting each other's work. What's next on the list?
So viewers, this is the session for Maya. Today we will meet you in another Maya session. Tab tak ke liye Allah Hafiz, Pakistan Zindabad.